Hello, today we are going to discuss very simple problem in recursion and DP series. So this will be more of recursion problem, how we can use and how we can discuss. So problem says that a child is running on a staircase with n steps and he can hop either one step, two step or three step at a time. We have to implement a method which will give us count how many possible ways child can run up to the stairs. So in all the cases where you can break problem in sub problems, those cases you can turn up into recursion or DP. So how we will know that this can fit in the problem of breaking into a small subset of the problems? First, it's a hunch thing. What you can do is, if it's not fitting in queue, stack, array, search, map, and reading from both sides, using DQ, using linked list, all those things are exhausted, then you can simply imagine that there is no problem, there is no way but DP can solve it. Whenever DP comes into mind, try to break problem either from start or from end. If you can break it from start, first try from start. If you can break it, it's good, otherwise try from end. So here if we try to start, in start we don't have anything, as from one step he can hop, two step he can hop, three step he can hop, and ultimately we have to find the nth one. So let's try to find out from the n. So suppose if we have to reach to n, there are how many ways? So there are three ways. What he can do is, either it can hop from n minus 1, either it can hop from n minus 2, or it can hop from n minus 3. So what we can think of is that by how many steps it has reached to n minus 3, and similarly n minus 2 and n minus 1. If we add up those, there is one more step he can do on top of that. So to find out that, if we add 1 in that one, then it will reach always to the top of the step. So if now comes the point is that if we should add the n minus 3, n minus 2, n minus 1, or we should multiply them so that we will get the desired result. So if we multiply them, multiplying means that we are trying to find out different paths. We took one, then we break this thing, then we took one, but it's not the case. Here the case is that you have to continue on the same path where you have chosen. So suppose you have hopped from n minus 3, you have reached to the n. There is no breakage from it, you have to find out the paths going on it. Now comes the pseudocode. For pseudocode, what we can have is, if stairs are less than 0, then obviously there are 0. If it is n is equal to 0, then we are considering at 1. Why we are considering at 1? That one step where n minus 1 plus what we have did, that we are doing as part of 0. So when we are at 0, we are considering this at 1, so that n minus then 2 then 3 for those things will keep get added plus 1 in the steps. And then finally what we can do is count ways n minus 1 plus n minus 2 plus n minus 3. As we have already counted 1 floor 0, so which will get embedded in this thing. And the complexity for this will be O of 3 per power n. What will happen is that with every branch you will be having 3 steps to go. 3 types of hop he can do. From this you again have 3 per possibilities to go. From here also you have 3 possibilities to go. So it will be 3 to the power n, the complexity, if you are not doing any memoization. So if we do memoization, then it will become very simplistic problem, because each and every step, as we keep calculating, we will have the calculations done. So suppose if we are here, then we will not have to do this again. This all value is saved at its immediate node. So we will have to travel only one step back and we will get the information. So one more thing what we can say is that if you will keep calculating, beyond 37 you cannot go. After that it will go beyond the range of the n. So in LeetCode it's a problem number 70. There they have said that only 2 steps are there. So here is the problem number 70, climbing stairs. If you are climbing stairs, it says that only either it can hop 1 or it can hop 2. So for this solution will be simple. If n is less than 0, n equal to 1, then return 1, otherwise climb n minus 1 and n minus 2. This will give you time limit exceeded, because we have not done memoization, and it will go to 3 to the power n, which is a very huge number. Then we can solve it by memoization. If we solve it by memoization, it goes 100% faster and it takes 0 millisecond, as it is the result shown here. So here what we can do is we can declare a hash map. In that hash map, whenever we found out the value, we can put that value. Otherwise what we can do is we can calculate. So in the last step, if you see, when we did not find anything, then we have first whatever value we have calculated, we have saved against it n and then returning the value. Otherwise we are trying to get the value from cache, whatever we have used, and trying to return it.